produced and then destroyed again. At the top of the hydrogen burning region where the temperature is lower, helium-3 is relatively more abundant because it is produced more easily than it is destroyed. So look, even how it converts hydrogen to helium, there is like a variety there. And so different isotopes of helium, some are more stable than others. Even some of this stuff happens and gets either made more or destroyed, and depending on, that there's, dude, some people only study the sun. I don't know how, because that would be so boring, but some people literally only study the sun, even the sun has so much detail. Like, this is crazy. If you're looking at things sort of more broadly, you might not spend that much time on the sun. Like, personally, me, I did not spend too much time on the sun, but even our sun is pretty damn interesting. Wow. The largest contribution to the energy production in the sun occurs at approximately 1/10 of the solar radius, as can be seen in the sun's interior luminosity profile and the curve of its derivative, blah, 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 blah. Okay, whatever. We get it. So there's some things going on in the sun with regard to its mass fraction, hydrogen, helium, temperature, luminosity. I just want to know how the sun's gonna die. I know it will become a giant. I just want to know, where do they talk about that? This book has a lot of stuff, so I didn't cover every single thing. So I'm finding out with you guys here. One of these days I have to, one of these days I have to go and look at the Aurora Borealis. So the sun has a cycle, the solar cycle, sunspots. You guys probably know about all that. Solar cycle, sunspots. It was Galileo who made the first telescopic observation of sunspots. Sunspots are even visible occasionally with the unaided eye, but making such observations is strongly discouraged because of potential for eye damage. Reliable observations made over the past 2 centuries indicate that the number of sunspots is approximately periodic, going from minimum to maximum and back to minimum again nearly every 11 years. The average latitude of sunspot formation is also periodic over an 11-year cycle. Wow. So all of that, you guys probably know about the sunspots and things like that. What I want to, solar flares are eruptive events that are known to release from 10 to the 17 joules of energy at the lower detection limit to as much as 10 to the 25 joules of energy over time intervals ranging from milliseconds to more than an hour. Blah, blah, blah. Are they gonna tell us? So looks like this chapter doesn't really talk about the sun's death. It could be that we didn't talk too much about the sun's death, maybe because people don't really want to think about our death, right? Our planet's death. If the sunspots are periodic, does that hint that the sun is rotating? So the sunspots have to do with some of the most fascinating and complex features of the solar atmosphere are transient in nature. However, as we will learn in this section, many observational features of the solar atmosphere are also cyclic. So the key to understanding sunspots lies in their strong magnetic fields. A typical sunspot is shown here. Let's look at a sunspot together. Here's a sunspot right here. A typical sunspot group. The dark umbra of the central sunspot is clearly evident, as is the filamentary structure of its penumbra. The darkest portion of the sunspot is known as the umbra and may measure as much as 30,000 kilometers in diameter. For reference, the diameter of the Earth is around 12,000 kilometers, so just one of the sunspots can be 30,000. The umbra is usually surrounded by a filament-like structure called the penumbra, whose mere appearance suggests